Hello, welcome to the cSRX Docker Compose Learning Byte. I'm Gordon with the Education Services Department at Juniper Networks. Let's get started. After completing this learning byte, you will be able to use Docker Compose to manage cRPD instances. The cRPD, or the Containerized Routing Protocol process, is the Juniper routing protocol daemon separated from the Junos OS and packaged together in a container format. It contains a limited set of Junos processes and supports ISIS, OSPF, and BGP routing. So anytime you need routing services in a containerized format, so rapidly deployed, highly scalable, highly advanced, feature-rich routing services, this is a use case for the Container Routing Protocol daemon. I used the cRPD to learn Docker, to build myself a little lab, and to learn about using Docker Compose to deploy a simulated lab environment. So here are the steps, right? It looks like a lot, but it's really simple. The first thing you need is Docker. I created this learning byte using a Windows laptop, so I downloaded and installed Docker Desktop for Windows. There's a version for Mac. There's also a Linux version. Now you need to verify that as part of the Docker installation, Docker Compose was also installed. It's installed by default when you install Docker Desktop for Windows, but from what I understand, for example, the Linux version of Docker, Docker Compose is a separate installation step. Then I need to download the container, the cRPD image from the Juniper Network support download site, and then load that into a Docker repository. I'll show you how to perform that step. Then the magic is in creating a Docker compose.yaml file. This is a YAML formatted document that Docker Compose processes and uses to manage your cRPD instances, to both create them, the networks, the volumes that have to be created, all in one step. This file contains all of the instructions used to deploy and destroy your cRPD instances. Once the YAML file is created, we'll use Docker Compose. We'll use a Docker Compose up. The -D option will launch your cRPD container and in detached mode, so you get your command prompt back. And then when you're done, you can, and want to destroy the cRPD instance, you run a Docker Compose down. The -V option is an option. It's not required, but that not only destroys the container image, destroys the networks, but the -V option also destroys any attached volumes. Right? Now, once the cRPD is launched and running, just like any other Junos platform, you need to install a software license and also apply some Junos configuration. Here's an example of using the Docker Compose command, the Docker Compose up -D to run in detached mode, so I get my prompt back, and it will load the Docker Compose file I have created creates 3 networks. I'll show you those networks. It also creates 2 volumes. Each cRPD instance needs a volume to store its configuration data, and also another volume to store logging information. So since I have 2 container routing protocol daemons, I'm going to create 2 volumes for each instance, and then the containers are launched. It takes a few seconds to actually launch the containers, and then when I'm done, I run the Docker Compose down and use the -V option to also remove any attached volumes that were created when these containers were launched. So this is launch it, and this is destroy it. Now the example that I'm going to create for you, it matches this diagram. We're going to use Docker Compose to launch 2 cRPD instances. There will be 3 Docker networks created. There'll be a management network, another Docker network called TransitNet 1, and a third one called TransitNet 2. Now, these are network names or variables. You can call them, label them however you wish. And there will be 3 interfaces available on the cRPD instances. By default, the first interface that's instantiated on a cRPD container is the Ethernet 0 interface. That's by default the management interface. It will be associated with the management network. And then the first transit interface is Ethernet 1. It'll be associated with the TransitNet, and Ethernet 2 will be associated with TransitNet 2. And so this is the environment that I was able to build and instantiate in a matter of seconds using Docker Compose. And I use this to learn a little bit of OSPF and BGP. So once you get them up and running, they can communicate with each other. They are assigned IP addresses. Then you can begin configuring the routing components on these container instances. Let me show you some example commands. I have in this notepad document the commands that you would enter in a command line to create these RPD instances manually. Remember I mentioned that each RPD instance requires two volumes, one to store the configuration data and another to store logging information. So I would use the docker volume create command to just manually enter these at a command prompt. There were three networks I wanted to create. This is the management network. Again, these are variables. You can name the networks however you wish, but then I also manually created a subnet range. Docker will automatically assign subnets if you don't specify that, but I wanted a little more controlled. And then finally, I use the docker run command to actually launch the instances, right? There are options, for example, to publish specific ports. So I can connect to port 221 on my host during a PuTTY session. It'll connect me to the SSH port on this running routing protocol daemon. I can also, publish a netconf port so I can configure this device using automation. I want it to run in detached mode, so I get my prompt back. This is going to be the name of the container. This would be the host name that's configured in the cRPD instance. It runs in privileged mode. When it launches, it will connect to the management network. The -V option connects to the volumes. And I'd run very similar commands to launch cRPD too. But I'm doing this manually, and then once those instances have been launched, then I need to connect the networks to those launched instances and assign an IP address to the network, to the interfaces that are on the instance that actually connect to these networks. And then once this process is complete, my containers would be up and running. They're on the network. And then I can use the docker exec command to access each instance and then, install a license and begin the configuration process. So this is quick. It's a container, but it is a manual process. Here's a docker compose.yaml file that I created that will perform the exact same functions as the commands that you saw on that previous screen. I want to scroll down to the bottom and start first by looking at the networks section. Remember, we were going to have a network called management_net. I configured a subnet range to be associated with that. Here's a transitnet_1, transitnet_2 with the subnets also associated. This is exactly the same as running the docker network create commands manually 3 times. Let me define it in YAML format in this docker compose file. So those are the 3 networks. I also remember that each cRPD instance requires a config volume and a logging volume. So those are defined. Now I want to scroll up to the services section in this file, and this is where I specify the individual values for each RPD instance. Here's cRPD01. Here's the image. This is the name of the actual container image that's in my local registry. I'll show that to you. The container will be called cRPD01. Here's the host name. I want to attach, I could do this manually with the docker network connect command. Let me just specify it in this docker compose file. I want it to connect to the management network. This is the IP address I would like to be assigned to the management interface on this container. I also want to connect this container to the transitnet1, and the interface would receive this IP address, transitnet2, and attach these 2 volumes. I want to set the root password, right? And I do very similar configuration options for cRPD2. We're going to load the same container image. We're going to set a different host name attached to the same networks, but let's give it a couple of unique IP addresses and connect it to its own unique data stores, its own unique volumes. So using the manual commands, learning how to format those same options in YAML allows me to open up a command prompt and simply run a docker compose command and have docker compose process this file and instantiate all this infrastructure for me, right, in a matter of seconds. Let's go access a command prompt now and see how this works. Now I'm on Windows, so I open up a command prompt, and all of my files that I need are in this cRPD folder. I want to do a dir Now here's the actual cRPD image that I downloaded from the Juniper Network software download site, right? And then once I download that file, I run a docker load -I, and then the name of that image, that software image, that container image that I downloaded. Now this will unzip and uncompress this container image and load it into my local Docker registry. So then I can deploy a container using this image. This takes a minute or so to actually do, so I actually performed this step before the learning byte. You can see the actual image. I can do a docker image ls command, and this is my local image repository of images that I've loaded, locally. And here's the cRPD image. It's cRPD, and this is the version number. It's tagged. This is the most recent version of the cRPD container that was available when I created this learning byte. So I've already downloaded it, and then I use the docker load command to place it inside of my local repository. And at this point, let me show you that let me show you a before picture, right? I can run a docker container ls. I don't have any containers running currently. The only networks that I have are the built-in, Docker networks that you get, just from the standard Docker installation. I don't have any volumes available either, right? So I haven't configured anything. So this is just a fresh start. I'm going to run a docker compose up, right? This will allow docker compose to process the docker compose.yaml file that's in this cRPD folder, and I want it to run in detached mode, which means once these containers are launched, I get my prompt back, so I can keep using it. So let's spin this up. So it's creating the networks, right? The 3 networks that we had created. It created the 2 volumes for each container instance, and then it takes a few seconds for the 2 containers to actually start. So in a matter of seconds, less than 10 seconds, I have 2 containers connected to 3 different networks and 2 attached volumes. So let's take a look at what's there. Let's run a docker container ls command again, and here's my cRPD01, cRPD02 instances that are running. We can look at the networks that were created. Now we have a management network, TransitNet 1 and TransitNet 2. I can look in detail using the Docker network inspect. I can look at any network really, but let's look at the management network. And you can see it'll show you the containers. There's a little bit of output here, but these are the 2 containers, cRPD02, cRPD01. These are the IP addresses that they were assigned. These are the management IP addresses that I could, for example, secure shell to connect to the device, the MAC addresses that they've been assigned. I can look at the volumes. I can inspect those and see what containers they're attached to. So just simply running that docker compose up command along with that YAML file, I've created all this automatically without having to manually type in all of those Docker commands. I can also connect. If you'd like to connect, we can run a docker exec -it. I'd like to start an interactive terminal with cRPD. These in there, 01. It's a Junos CLI. Now that I'm connected, I'll run a show interfaces. The interfaces in cRPD are named ETH as opposed to GIGI000 that you may be accustomed to or that shows up in a cSRX instance. But in this example, Ethernet 0 is the first interface that's instantiated. It's assigned to the management network, the management net. This is the IP address it was configured to receive. Ethernet 1 is the first transit interface with a configured IP address. Here's Ethernet 2. Now, there is no Junos configuration by default on these cRPD instances, so there's no license. I need to install a software license and then apply some configuration. I can also view cRPD02. Same interfaces, management interface with a different IP address. Ethernet 1 and Ethernet 2 were the only interfaces that I created. And again, with assigned IP addresses. And so that's an example. Let me exit back out of here. And now I can run a docker compose down, and then I'm going to include the -v option to not only destroy these two containers, but also delete any volumes that were created. So I run this. It seems about maybe somewhere around 12 seconds, at least on my laptop machine, to stop the containers, and then it will delete the 3 networks and also the volumes that were created for each instance. So a pretty quick process to launch and then destroy those resources. Containers are gone. The management net and the transit nets are gone. And since we use the -v option on the Docker Compose down, all volumes have been destroyed as well. In this learning byte, we used Docker Compose to manage cRPD instances. Thank you very much.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.